Hello class, this is a video tutorial on probability density and cumulative distribution functions part 1. A probability density function, shortened for PDF, is a function that describes the probability or shape of a continuous variable event between two values A and B. So for example, if we had a random number generator, randomly selecting one between 0 and 6. This has a PDF of f of x equals 1 over 6. For the values 1 is less than x is less than 6. Since all the probabilities have a 1 in 6 probability. So this is what it might look like. You might see this as something very familiar to a dice roll. But instead, this random number generator can pick any number between 1 and 6, whereas dice can only pick the numbers 1, 2, 3, 4, 5, or 6. So this random number generator might pick, for example, 2.3. It might pick the number pi in actual fact. Pi. Okay, so that is what a probability density function is. It is a function that represents a probability given a range. A cumulative distribution function is the sum of probabilities between the minimum value to any value x of a PDF. Since we now know that probabilities are related to the area of the graph, a CDF is the integral of a PDF. So for example, here is the CDF of the above probability density function. So the function that we were given before was 1 over 6. The probability that we pick any number from x down to 0 is the integral from 0 to any value x of the function 1 over 6. Integrating 1/6, we just get, 1/6x. And the function that we get, substituting this, x into x, 0 into x, that's 1 over 6 minus 0. Equals 1 over 6. So what this represents now is that what is the probability of picking, let's say, a number x is less than or equal to 3.5. Well, because we now have this this cumulative density function, we get that's equal to 1/6 times 3.5. That's equal to 1/6 times 3.5, 7/12, which is a 58.3% chance. So 3.5 is about here. So what's the probability that this random number generator picks any number from 3.5 and less? Well, that probability is given with this function, 58.3. So I know this is rather confusing to begin with, but I hope you understand that a PDF is merely a function representing a probability event, and its CDF is the integral of that value. So here are the features of PDF and CDF. The PDF f of x is defined between its given boundary a to b. The boundary will be given, or we have to calculate it. The main feature that we have to make sure that we understand is that the integral from the boundaries a to b of the PDF must equal 1. Since the sum of all probabilities in an event must be 1. The peak or global maximum of a PDF is its mode. This will be important much later on. The probability of events is equal to the area below the graph of the PDF. We've learned that before. The CDF is the primitive function, capital F of x, of a PDF f of x from the lower bound a to any given value x. So the CDF is actually equal to the probability from the lower bound a to any value x, which is just the integral of the PDF from the lower bound a to x, and we can find that using capital F of x minus f of a. Notice how this is actually just the integral, the definite integral of a function. The probabilities between two values, h and k, is the integral between those two values. So the probability from h to k is just the integral from those two values of the given PDF. Probabilities of a particular value is 0. So if, for example, in this example, what's the probability of picking exactly the number 2? So let's say this one here. What's the probability of picking the number 2? It's actually going to be 0. Reason for that is that the area of any particular point, let's say h to h, well, if we go through the definite integrals, we get f of h minus f of h. That's just 0. Now this will make a lot more sense when we do an example of this. The PDF of a particle appearing inside of a 10-meter circle to be x meters away from the center is given f of x equals 1 on 50 x. Let's calculate its CDF. So this here, let's do this in purple. This is our probability density function, PDF. To find its CDF, cumulative density function, we take the integral of f of x between 0 and x. 0 to x of 1 on 50 x dx. Integrating this, I'm going to factorize the 150 out. 1 on 50. 0 to x of x dx. This is equal to 1 on 100 x squared from 0 to x. Well, that just gives us 1 on 100 x squared. So this here is our CDF. What is the probability it is 2 meters from the center? Well, that's just the same as the CDF, and if we substitute the value of 2, because this is the same as the probability of x is less than or equal to 2. Well, that's just 1 on 100, 2 squared. That's 4 on 100, which is 0.04, which matches what we previously saw. What is the probability? It is between 2 to 3 meters from the center. That's the same as from 2 to 3 of the function 1 on 50x. You could integrate it again like so, but since we already have the integral, that's the same as 1 on 100 x squared from 3 till 2. That's 9, take away 4 on 100, which is 0.05. What's the probability? It is at least 3 meters from the center. That's the same as from 3 to its maximum 10. Well, we already have the CDF. That's 1 on 100 x squared from 10 to 3. That's 100 minus 9 over 100. It's going to be 81 over 100, which is equal to, 91, which is 0.91. So I hope that gave you an insight into probability density functions and cumulative density functions. Hope to see you in the next video. Best of luck.